Hello, everybody, and welcome to tonight's vBrownbag US. It is Wednesday, April 6th, 7:32 Central Standard Time. Tonight we've got Joel here joining us to talk about, well, Joel, why don't you tell us what we're talking about?
Well, we are talking about storage networking for our CCNA data center test 64916. I know most people working on the CCNA track have probably come from the network side of the house. I actually came from systems and storage, so I'll probably have a little different viewpoint than most of you guys preparing for this test, and hopefully that'll be a helpful thing, not a harmful thing, and we'll give you guys some different views on these technologies and get everyone to pass on the test, hopefully.
Sweet action. Joel Sprague's joining us. You can see his Twitter name at the bottom, JWS Consult. Follow him for cool things, or don't. I apologize if you hear some noise in the background. I've got she's 3 weeks old today, daughter in my lap. So I'll mute myself when I can, but if you hear weird noises, don't be alarmed. Just some quick housekeeping before we start. If we go to the next slide. So, of course, as always, get in on the conversation. I'll be watching the Twitter hashtag tonight, vBrownbag, so you can tweet any questions, comments, concerns. I will interject and try to get those answered for you. And, of course, our other handles from around the world. vBrownbag schedule you can see in the middle. I won't read that off to you. You can always see it on our website, vBrownbag. And speaking of the website, if you have looked at it lately, you'll notice it has been redesigned. Something we're working on a little bit and making a little more tweaks to. Maybe someday I'll eventually be listed in people that are part of vBrownbag, but you know, that's cool. So check it out and let us know what you think. Again, our guest this evening for CCNA Data Center is Joel. I'm Anthony Hook. You'll follow me on Twitter if you care. And with that, I'm going to hand it over to you.
Okay. I will give the same warning that she's not down yet, but my 3-year-old may be joining us here too, so it'll be an interesting night. Let's see. Can you guys see my screen here at all?
Yeah, I could, I can't, and now I can again.
Okay, so I expect most of you are here. We're probably here the first few sessions with Shane. Like Shane, this is my first time doing this. I've shown up to a lot of the vBrownbags, but first time here in the driver's seat. So a little nervous, but hopefully it'll go well. I actually had huge PowerPoint notes for every single slide written out and everything, and realized I'd be putting you all through PowerPoint hell. So I deleted pretty much all my notes, just kept the graphics to work from, and hopefully it'll make things a little more natural. It might be a little scattered, but I think we'll be able to get a good coverage of everything going on. Though hopefully I'll remember that if I click the mouse, it's going to advance the slide. So we are, as I mentioned, looking at 640-916, which is introducing data center technologies. This is just a brief overview of most of the topics that you will see for this section in the test on the blueprint. There's a few sections that I skipped on verifying, which I'm going to try and do with a live demo here at the end during the initial setup. There's also hopefully we'll get to some coverage of the MDS family. It's not listed on the blueprint, but as we know, the CCNA level tests are a lot of just rote memorization, and the test writers, especially when they're directed to come up with a new version of the test to deal with dumpers, love those charts of, you know, cards, supervisors, what does what, which cards have how many ports at what speed, and so on. So as much as we all hate it, you're going to have to memorize those charts. And then at the end, we'll hopefully have a Q&A if anyone has any questions. If I do my job, hopefully there'll be no questions and we'll all be done for the night. Okay, so this, of course, is the official cert guide. It is on the third printing. It is great. Every single one of those authors has I think anywhere from 2 to 4 or 5 CCIEs. These are the guys who work for Cisco, help design all this equipment. They know what they're doing. This is well worth reading, even if you're not taking the test. Get it at Amazon, Kindle, Safari, wherever you like. You guys know how to find books. This is the breakdown of the test. Again, Shane's gone over it, so I won't get into it too much. One thing to know as you get into the higher level tests is this data center network services kind of disappears. The ACE load balancers are still on the blueprints, but they aren't really in the higher level tests or labs, but you still need to know a little bit. Today, though, we are going to concentrate on this green section, storage networking, which is why I got picked to do today as a systems and storage guy rather than a network guy teaching. Here's a few other links. I know the CCNA, there's, as far as I remember, as of 2 years ago, there's nothing hands-on in the test. But if you're like me, the only way you're really going to understand and really commit these things to memory is if you do them. Luckily, if you work for a Cisco partner, they have multiple ways of you getting in and not only just learning, reading, but actually doing things hands-on here. So there's actually 3 main sites you can go to for hands-on labs as a Cisco partner. My favorite are the Partner Education Connection. They have, for pretty much every track, there are labs. The security and service provider, as you see, it's actually a full curriculum written as prep for the CCIE, which is more than you need to know, but if you can get through these labs, even working along with the study guides, you're going to know everything you need to know about those tracks. It's the same thing here. We have our data center virtualization, which is what we're looking at. So you click in here and you will have access to not simulators, but actual live hardware. You know, Cisco data center rack costs just shy of $1 million list price. As working for a Cisco partner, you have access to all of that equipment here for free. Just have to fight with the scheduling to share it with everyone else. And they have really good labs written up, which you'll see that'll walk you through full configs, the base ideas that things are based, you know, that they're working off of to help you understand zoning, network switching, whatever you're working on. We'll get back to that later. I'm going to actually use one of these labs for the hands-on demo towards the end tonight. Again, same idea, dcloud. PEC is targeted at training partners. So this is so you can know what you need to do before you talk to a client or do your job. dcloud is targeted more at doing demos for potential or current clients. But again, there's still all kinds of Nexus labs, and they have changed the site since I was last in here. Sorry about that. Here we go. Data center virtualization.
What happens if you're not a partner? You said you can get some rack space actual equipment if you're a partner. You just have to schedule it. Can you do that, or what are your options if you're not a partner?
Your main options then are spending money, and the best place to do that has sadly gone out of business just recently. Some of the dcloud, including the ACI lab, which I believe is this one, which we're all trying to learn with the new versions of the tests. Robert Burns at Cisco is actually trying to make available to everyone rather than requiring gold partner status. Outside of that, though, there are certain things which I should have added here. For UCS practice, that's actually the best situation. Cisco has a UCS platform emulator, which is a small virtual machine that you load up, and you can basically do about 90% of what you need to learn playing with Cisco, probably 100% in CCNA. It does 90% even up through the CCIE level. And obviously it doesn't have any actual hardware, so you can't boot up the servers, but you can practice all of your configuration, creating templates, everything you'll need, which is what I'll be talking about next week, so I can actually have that in my PowerPoint. But then other than that, you're basically looking at your regular commercial rack vendors, which are never cheap, but especially as you move, if you want to move past the CCNA level and if your work doesn't have things around, you have to spend something. That being said, a lot of this gear is not necessarily end of life, but is at the 4 to 6 year mark. So you'll see a lot of corporations are replacing equipment and stuff is available relatively cheap on eBay. I would highly recommend, if you have a friendly boss, either convince them for rack time, or if you have a very friendly boss, a little budget and a spare rack, see if you can pick up some of the older hardware, the Nexus 5, the 5020s, the Gen 1 or Gen 2 UCS blades, and get them set up in a rack and set up a test lab for you to play with. Nothing's ever going to replace hands-on work, whether it's CCNA or CCIE. I have been lucky enough, I actually got started on this whole track. I had one expired Cisco certification from years ago and got started on the data center track because we have been using UCS servers, the blade servers at my day job for, I think, coming up on 6 years now. And I was in charge of the storage too, so it just made sense for me to start on this track, and because it fulfilled some of our partner requirements, I was able to get work to pay for all the testing and training, which never hurts. Okay, so that
is and we had one other question on that. Is Viral of any use for the data center stuff?
It is. Viral and GNS with the NX or the NXOS module, it'll do about 40 to 50%. It's missing most of the layer 2 functions. It'll definitely get you familiar with NXOS, let you practice some of the stuff, but a lot of the layer 2 functions will not work. In addition, if you just are looking for exposure to NXOS, you will see, I'm a huge believer in VMware as a system and storage guy, but also because there's so much stuff now that vendors make available either as a VM completely or at least emulator, so you can, with a very small server, practice things. So you will see here I have the UCS platform emulator, the NetApp emulator, the F5 Big IP emulator, EMC emulator, here we go, the Nexus 1000V. That's the Nexus 1000V, which we're going to go over next week, is the virtual switch that lets you do basically a software-based switch for your VMware or Hyper-V environments, and that again runs the same NXOS as the physical switches, so lets you practice setting up, all your regular VLANs, port channels, stuff like that, as well as the port groups and everything that are involved with the integration between the Nexus and your VMware hosts. Okay, so let's get to storage. Basically, in the world we're used to, there's 3 types of storage. You have your direct attached storage, that is whether that's the hard drive in your laptop, RAID card and hard drives in a server. It's very simply, the controller, the disks, the cable, it's all within the server itself or the laptop itself. It goes a little bit further. You can have external SAS arrays, but still, it's generally connected to a single server. Occasionally you'll have it connected to two, but most of the time, even within most of the external disk packs that connect to two servers, they split up the disks. You'll get 7 disks on one server, 7 disks on the other port. It's simple as that. Moving past your direct attached storage, you start to get to your network attached storage. I think everyone in here has probably used it. They've never thought about it. Anytime you're mapping a network drive to a file server, whether it's a CIFS server, NFS, whatever that is, this is network attached storage. It can be a Windows file server. It can be a Synology NAS with a CIFS program running. It can be a Linux server. Anything you're mapping a network drive to from your workstation is network attached storage. And then finally, and what we're really looking at for this test is storage area networking. With this, it's similar to NAS. You're still using servers that are connected to storage over a network, but it is generally not going to, well, it's about 50-50 these days. It'll be either an Ethernet network running FCOE or iSCSI, or it'll be a dedicated Fibre Channel network, which is a Fibre Channel is networking dedicated to storage. So it's specifically, you know, your regular TCP/IP network. You have drops. You have, you have to act packet, react it, resend if need be if it's corrupted. Storage doesn't like that. A server, if you have storage, if it's boot disks or database storage, it wants that data to always be there, get there in order, have no corruption, have no drops. Fibre Channel's designed around this. iSCSI is used often these days. It's cheaper. It can use your existing network, so it lets you do smaller scale implementations. You don't need dedicated Fibre Channel switches. But if you talk to an old storage guy, he'll basically call it kid stuff and say to get Fibre Channel if you aren't real storage. I don't know that that's the case anymore. You get a nice hybrid setup or a pure flash setup running 10 or 40 gig Ethernet, and it'll blow any of those old Fibre Channel arrays out of the water, but you can't convince an old storage guy of that. So here we have a chart of, as an aside, most of these, like this graphic, is straight out of the official certification guide. Nothing too surprising. Not all my images will be. I tried to get some things. I like to teach by analogy, so there are going to be some that aren't out of the certification guide. You'll be able to tell when that happens, and hopefully they'll help explain the ideas a bit better. So here we have, most of these things we've already talked about. So file level storage, that's anything you're mapping a network drive to. So that can either be CIFS, NFS, it can be a dedicated appliance like a Synology, it can be something like an EMC Solera, which takes block level storage from your backend SAN and basically acts as a CIFS server to allow Windows clients or an NFS server to allow Unix clients to write to it without having to format it and create their own file systems on there. iSCSI, SAN, direct attach, these are all block level storage. What that means is there's no file system, it's just raw storage that the server it's raw storage that's being presented to a server that the server can do with what it wants. It's going to have to format it, it's going to have to put a file system on it, but then it can boot from the storage. The storage with a SAN at least can be presented to multiple hosts, which lets you do things like SQL clusters that share a CSV volume, and of course, the most common virtualization cluster that has shared storage. So if one host goes down, that VM is not going to go down with it. Any VMs on that shared storage can be brought right back up on another host, and it lets you just keep running along as pretty as can be. This I just threw in there. I couldn't find a better place for it. This is one of our dreaded charts. SCSI, fast SCSI, ultra SCSI, you don't see these anymore. I think Dell shipped their last SCSI server might not even have been the 28950. It's probably the 2850 about 8 years ago. But you're looking at one of these charts where this is the things I love to test on. So I like to try and group these to memorize these numbers, try and find where things are grouped that you can put together. So anything that just starts SCSI, you have a 6-meter cable length. If it starts just fast or wide there, you have 3 meters. Just plain ultra, 1.5, ultra 2 or 3, 12. You know, stuff like that. Everyone is going to have a different way of doing it. You have to figure out what works for you to let you memorize it, but for better or worse, these charts are things we've got to memorize. You'll never, you know, unless you're old like some of us, you've probably never seen any of these, but memorize your numbers. Or don't, and just hope that you know enough of everything else so you can pass the test. Okay, I decided to follow on with Shane here and get at least a few practice questions in. So our first practice question is, which of the following options describes advantages of storage area networks? I'll give you guys a minute and then we'll go over that. The answer to this would be A, B, and C. SAN, because the disks aren't just stored in the servers themselves, they have a lot of advantages. Not all of them are directly related to SANs, but they're things we've come to expect on SANs anyway. The consolidation is kind of a given. You know, you have all these spindles that instead of just having 3 in every single server in the rack, you have them all in one place. It lets you put a whole lot of spindles in a small footprint. I think my latest NetApp trays are something like 48 spindles and 4 rack units. And they also then, of course, let you get better performance out of it. Instead of striping your data across 5 or 6 disks, you can stripe it across 30, 60, 90, you know, it just scales up. Storage virtualization, we're not going to cover that really today. It's not on the blueprint. It is in the official certification guide. It has a whole section. Read it. The stuff is in the test. I was just running out of room. As you see, we're already 20 minutes in, and we're on only a third of the way through the slides. I guess that does work. But this is just the abstraction layers. You have, you know, 15 disks in a RAID group. You abstract that to an aggregate that has, instead of 15 terabytes, it's 13 terabytes a disk because 2 are used for parity. Then there's another layer of storage virtualization and abstraction, and that aggregate might be split into 5 volumes presented to 5 different servers. And then within those volumes, you can abstract and virtualize again and say put 2 or 3 LUNs in each one of those volumes. It's similar to what you're doing, taking your 2 CPUs and 256 gigs in a VMware host and presenting it out as virtual hardware to 30 virtual machines, just with storage instead. And then business continuity. You have all these disks. The SANs give you have more spindles, so you can have more parity disks. You can have more spares. You can do replication between arrays. You have deduplication and compression, which allow you to get more use out of your disks. It just lets you just basically gives you a whole lot more safety, a whole lot more ability to replicate to other sites, just trying to take out any single point of failure, which is something you will hear from every storage engineer ever. Multiple controllers, multiple ports on every controller, multiple storage fabrics. Storage guys do not like single points of failure. So now we're going to look at SAN connectivity. This little chart here is just trying to show you that whether you're talking SCSI, iSCSI, Fibre Channel, FCIP, Fibre Channel over Ethernet, Fibre Channel, these are all just methods of getting SCSI commands from your host to the disks over a physical wire. So SCSI It's simple. It's SCSI commands directly, the controller's directly connected to the disks. Nothing too complicated. Fibre Channel, well, let's go back over here. iSCSI, you're taking those SCSI reads, writes, you're putting them up just on your regular TCP/IP network. This is why iSCSI, one of the big reasons why you always want to run MPIO or multipathing on iSCSI in particular, but in storage in general. Because, we all know TCP/IP over Ethernet, it's lossy, there's restarts, you mess with MTUs, fragment your packets. It's an ugly standard, but it's also just resilient, so we use it for everything. And iSCSI has made use of that and just tried to make it work well with storage. Fibre Channel, this is the old school storage protocol. There's not a whole lot to the stack, but it's written to make sure that your data is always there, it's always accessible, that doesn't get lost. If your boot volume is trying to boot up and you lose 3 out of 17 packets, your server's going to crash. So that's what Fibre Channel has been written from the ground up to do. There's, you'll see in the next slide, it uses 8B, 10B encoding to have extra bits for parity. It uses buffer-to-buffer credits. iSCSI, you throw packets out there. It's TCP, so you look for an ACK, but you basically throw packets out there. As long as they get ACKed, you just keep going. If they don't, you resend them. Fibre Channel doesn't work that way. Fibre Channel, the receiver actually says first, I'm available, I'm ready, I can take 6 blocks, 6 frames, sorry. So then the sender will send 6 frames and will not send anything else until the receiver says, okay, I've processed those, I'm ready for 6 more or 4 more. That way, you're not losing things to, things getting lost in buffers that are full, anything like that. FCOE and FCIP, you're basically taking your Fibre Channel and either at layer 2, FCOE, it uses your typical MAC address, everything you'd think of on Ethernet, or layer 3, FCIP, which goes over TCP/IP, and then still is just packaging up these Fibre Channel frames. These are, again, Fibre Channel on its own requires a dedicated Fibre Channel switch or a unified fabric. It can be expensive. FCOE requires an FCOE capable switch. It's not going to work on every switch, but it works on more than just the FC. It lets you share the traffic. An FCOE connection will generally be a VLAN trunk that has 1 VLAN for data, 1 VLAN for regular network data, and 1 VLAN for storage traffic. So it lets you save a lot on not just switches, but cabling, your plant costs. FCIP is mostly used for extension between data centers or pods. It's taking those Fibre Channel packets, throwing them over a layer 3 network, and letting you get further out with it. It's not particularly efficient. It's nothing you're going to want to boot over or use for high throughput traffic, but it works. Another, just one of our wonderful charts here. Fibre Channel 1, 2, 4, 8, 16, 32. Memorize. I don't remember at all what I saw, but I would guess, if you wanted to know, memorize your speed, make sure you know 8, 10B encoding, and have some idea of how to convert from GB to MB. If they do ask you one of these, they're probably going to give you one or the other column. Know that it's, do the math with 8. This is pretty basic networking. You should know this by now. Fibre Channel has its own kind of topologies. If you've done route switch, particularly the older tracks, some of these will look familiar. this looks a whole lot like the first is point-to-point. Your server's plugged into storage. Anyone can think of that. Fibre channel arbitrated loop. If you've ever done 10base2 or FDDI or even study them, it's a very simple, very similar idea. You have a single loop. Only one device at a time accesses it. It only goes one way. Fibre channel hubs are actually still a fibre channel loop. I think Shane went over this already, but basically you have a loop that goes up, down, up, down, up, down. And then a switch fabric, it's basically what you're used to with Ethernet. Fibre channel storage we do the same core edge core designs or collapsed core designs, because despite the different protocol, the math of what makes for a redundant network, if this dies, say, you lose this link or this link, it's the same thing for redundancy with fibre channel as with Ethernet.
So we had a question quick. If you can go back to that previous slide.
This one?
And on the right, on the right side, fibre channel switch fabric topology. What is is there a good number or a maximum number of hops that you want to try to get or try to stay under for fibre channel frames?
There is. It's not actually a per frame. What you're looking at is, which we'll cover here. Well, let me hop ahead to this next one, and I'll be able to explain it to the answer to that question. So we're going to look at this. There's two bits of addressing for fibre channel. You have your worldwide port names, which think of this like your MAC address for Ethernet. Every device is going to have a node worldwide name, which is unique to that node. And then each port on the controllers has their own port worldwide name. So it's simple. Think of it as your MAC address. This is actual hardware address burned into the HBAs, or in UCS, the address that is pulled from a pool and assigned to it. But for the actual passing of traffic, fibre channel uses domain IDs. And this is where we're going to answer that question. Each switch, a domain ID has 24 bits. And the first, or an FCID, sorry, I answered it there myself. An FCID has 24 bits, and the first 8 bits are the domain ID, which each switch has its own domain ID. So when you're looking at fabric, the size of your fabric, it's not the amount of hops. Fibre channel limitations tend to be the amount of domain IDs on your network. How many that can be is going to vary by the vendor and model. I think with the MDSs and the Nexus 5000, Cisco suggests no more than 83 devices on a particular VSAN. And then once the other consideration is going to be, which I know Shane went over, is the fan out and the oversubscription, which again, it depends on the workload and on the vendor's standards, but what it is, you're doing the math of how many hosts down here are connecting to each port on the SAN on the other end, or vice versa, how many, particularly the UCS, how many blades are connecting out through, say, 2 or 4 fibre channel uplinks from the fabric interconnects down here. And the numbers on there, it depends a lot on the workload and on not just the switch vendors, but the SAN vendors, how many connections they recommend through them. Obviously, if you're doing giant OLAP transforms and SQL, you're going to want a lot smaller fan out than if you're doing VMware View or something. Desktops for regular office users are going to have a whole lot less load on the fibre channel ports than big database servers. And every vendor, every switch vendor, especially every storage vendor will be happy to sell you an application and consulting services to help make sure your storage is properly tuned for your needs. This is just going over the different types of fiber channel ports. Fiber channel ports tend to be a software entity, so the physical port is always going to be a 248 gig fiber channel port. What you're configuring is the type of port based on the type of traffic or connectivity it's going to be. So F ports, fabric ports, are always used to connect hosts, which are either N or NPV ports, which we're going to discuss next time. But basically, if you remember from your biology class, DNA coding, certain ports always go together, just like your pairs in DNA. So F is always going to go with an N. E always goes with another E. These are the expansion ports that you use to connect two switches together. TE, still an expansion port, but it's for, it's a trunking expansion port. So if you have multiple VSANs on your switch, which we're going to discuss further on, the trunking expansion port lets you run more than one VSAN over that link. FL, again, it's connecting to N nodes, but they're fiber channel arbitrated loop. So the L on the end is pretty simple. There's a few other ones. You'll actually see V, VF, VE, and technically TVE or VTE a lot. Once you start getting into FCOE, that the V there is just virtual. There's still, a VE is still just a connection between switches. VF is still a connection to a host. Nothing too complicated. The V is just telling you it's an FCOE port. Okay, we are back to another practice question. Which type of port is used to create an inner switch link on a fiber channel switch? I can give you guys a second to look through your 8 or 2 6-hole letters there to choose from. The answer, as we discussed, is the E port, the expansion port. Nothing complex, but make sure you know them. They're gonna, that's something you'll get questions on. Next up is initiator target. You'll see these terms a lot with storage area networking. The simplest way to think about it, think of a pitcher and a catcher. The pitcher is the initiator. This is your server. Anytime there is a storage request, it's looking for some kind of data, your server, the initiator, is going to initiate the request, throw the pitch down. This is your SAN, or the target. Catcher takes the request, looks at it, sends it back to the pitcher. So your server, the initiator, asks for data. The target here takes that request, processes it, sends it on back. A lot of guys I see getting confused at that, but it's really, don't overthink it. It's, even just look at the words themselves. Initiator, target. Initiator starts it, target is what they're sending that request to. This is the picture from the book on initiator target. Shows a little, you have your server, your storage. I put it in here because of this. I mentioned before the no single point of failure for storage. Most storage, with an Ethernet fabric, you put your redundancy by having multiple cores, multiple aggregation switches, but all connected together. Storage guys don't like that. They want to be able to say, upgrade their OS on their whole Fabric A switch infrastructure and not have it affect B at all. So they can do this without, I can take all of Fabric A down, do rewiring, upgrades, whatever. The service can keep communicating over Fabric B. They can keep running, processing requests. Nothing happens with it. And you'll see that with everything. Every controller head on your storage array is going to have a connection to both. So if you need to pull a controller head out, replace it, it's still, the other head is still going to have connection to A and B. It's still going to keep processing things. I didn't give you guys a question on that one. I think it's pretty simple. So describe, configure, and verify zoning. Everyone's watched some stupid school movie, seen the lunchroom where, you know, the tables are all split up by different groups. The students only talk to the other kids at that table, not to anyone else. That's zoning. You have, say this here.
You didn't hear me over here. I had my microphone muted, but I'm laughing. I wanted you to know that I had to unmute my microphone to tell you that I'm laughing over here.
I'm happy to hear it. I get laughs of that, but every time they see it, it's, I don't know. People seem to say, you know, look at this and like, oh, so you have here, you know, your school classroom, you have your 100% zoned out. Say that's your VMware host. Fat kids with awesome dessert, that's the storage. Those are just the disks with all your virtual machines. So the SQL servers over here, the Windows servers over here, none of them have any access. These VM disks are only communicating with the VMware hosts, or the fat kids are talking to the zoned out kids, you know. You can see this again here. This is the more official picture of it. IBM wrote probably 90% of the standards that we use these days in storage networking. So you'll see they have a big red book on storage networking. They have all the diagrams. You'll see IBM stuff in any discussion ever on storage networking. So I grabbed theirs for zoning. Say we have VMware host 1, VMware host 2. These ovals here are a zone. When you're doing zoning, best practice, well, technically, it depends on who you ask. Best practice, most people will say, at a minimum, you only want one initiator in each zone, or at a maximum. This is because, as we said, the initiators are the pitchers, so they're the ones who are going to start any conversation. And you don't want two hosts, or even two connectors in the same host, talking to each other. You want them just talking to their storage and then back to the host. You'll hear argument, and I've actually seen even just different, depending on which Cisco employee wrote it, whether you should do one initiator, one target, and that's it in the zone, or whether you can do one initiator, multiple targets. I'm lazy. I don't like writing, you know, with my infrastructure, I would have something like probably 500-600 zones if I did a separate one for each. So I do it by host 1, HBA 1, that's the initiator, and here's all your targets. It's, you know, there's only so much. My targets don't communicate to each other. Most of the time, they're two controllers on the same SAN. If they can't communicate, first of all, they won't communicate with each other, but if you're worried about it, you probably need to find a new SAN vendor, because if your two controllers are a security risk talking to each other, you have bigger issues. So whether you go with the fat kids or the official drawing, zoning, if you're teaching this as a network guy, they'll tell you it's like ACLs. I like my cafeteria drawing better. Either way, though, what it is you're basically defining who can talk to who. Describe, configure, and verify vSAN. So we are getting through this, which is good because it looks like we got about 14 minutes left here. I probably will run a little long. I'll try not to run too long here, either for the people here live or the people here who watch it after. I know we don't want to spend too much time on this. So your vSANs are like somewhere between your VLAN and your VRF. Technically, Fibre Channel does do FSPF routing for the traffic. So some people will argue that a vSAN is more like a VRF than a VLAN. I think that overcomplicates it. In general, other than some special cases where you're steering traffic, you don't do a lot with Fibre Channel routing. FSPF is resilient. It uses the same Dijkstra algorithm we're used to. It's generally best to leave it alone. So I tend to associate vSANs with VLANs. You have, you know, vSAN 1, these hosts, this storage, vSAN 3, this host, this storage, the two don't talk most of the time. This diagram is actually showing that in general, a zone is a zone is always tied to just one vSAN. I'll take that back. What we'll see here is that with the Cisco MDS switches, they actually will do inter-vSAN routing, where what you are getting here is, it doesn't show it, but you'll have vSAN 2, vSAN 3, say these two, say one host in here needs to talk to this disk here, but you need that disk in vSAN 2 for these hosts. You can actually set up, what inter-vSAN routing does is set up a third vSAN that translates and lets this traffic pass between these two so that you can have this host access this disk here. It's not a very common use case. It is supported on the MDSs. It is not supported on the Nexus switches. You'll see that for a lot of the stuff that is getting phased out that isn't used as often, they have not bothered implementing it in the Nexus, either due to silicon issues or just because there's not enough need for it out there.
Does that, on the Nexus, does the inter-vSAN routing require additional enterprise licensing as well?
Inter-vSAN routing does require, I don't remember if it's the enterprise package or which package it is, but it does require an additional license, I believe, but it's only on the MDS. The Nexus 5000 does not support it at all, actually. I may be able to tell you a second because this lab includes IBR. Oh, geez. Let's see, SAN extension over IP. I think it's actually the mainframe package. I can't swear to that. I was hoping it would be something with an obvious name, but of course it is not. But yeah,
and then we had
Yep.
one other question. Sorry, I'm not, like I said, I'm not trying to steamroll you. Somebody asked a question about the differences between hard zoning and soft zoning and what's recommended these days, or what the actual difference is for somebody that doesn't know.
Oh, I'm gonna say refer to the book on that. I don't think it's on the test, and I have gotten very different answers as to which is which, depending on if you ask Brocade or Cisco. I can tell you, Cisco devices use all hard zoning. They actually program the silicon, or it's the ASICs with the zones when you configure them, so that only the ports, or the ports that have devices that are zoned together, can talk to each other. Soft zoning, as to what that is, what the difference is between the two, yeah, I'm gonna say look at the thing, because I don't remember which is the Brocade answer and which is a Cisco answer, and I don't want to steer you wrong. I'm gonna throw that out on Twitter and see if anybody jumps in to see, if anybody has ideas or whatever. So we can come, that's a great question. We'll either come back to that or look for it in the book. Graham, let us know if you find anything, what you find out. Yeah, or, my Twitter was at the start. My email is going to be at the end. Hit me up. I'll get you the answer for it. I just would have to dig it up again. I don't want to give it to you wrong. I don't think it's on any of these tests, but just in case it is, I definitely don't want to steer you wrong in that case. Okay, so I'm going to quickly move on from the question I wasn't able to answer and give us a question I can answer. We are back to, I think this might be our last practice question here, which is, which of the following options are correct for VSANs? And we'll give you a minute here to read through them all. These are a little bit longer than our last one. Okay, the answer to this is A and C. I hope nobody said A and B, because if so, you aren't reading the questions, because it can't be only a single and multiple VSANs. So each HBA device can only belong to a single VSAN. As we mentioned, it can participate in traffic with other VSANs if you have and enable inter-VSAN routing. The 4 was a kind of a trick question or a trick answer, so don't fall for it. Yes, you can number your VSANs anything from 2 to 4093. No, you can't have that many. You're limited to 256 VSANs. It's actually operationally, it'll often be less depending on the particular capabilities of the switches you're using. So that, okay, initial setup. Actually, because I am running close, I want to throw out one more thing there. The certification guide is great, read it. The labs are gonna help you. I will say though, for additional training material, what I used primarily, other than the certification guide and just practicing, was Anthony Sequeira's videos from CBT Nuggets. For my personal learning, they were great. I like him a lot. He's a nice guy if you interact with him on Twitter. I do recommend, and I do try and do this for all my tests, do the videos for whatever test you're working on and the level above if you can. So I went through all of his CCNA and CCNP videos before I sat my first CCNA test. It may be overkill, but it saves you wasting $250 on a failed test. And I get nothing for that plug. Those videos work great for me. I highly recommend them. So now we're going to do the initial setup on a switch, which may be one of the last things we have time for here when we're doing the live demo.
And I don't have quite a hard stop at in 5 minutes here. So if you go a little bit longer, I'm okay with that.
Okay.
So, just so you know.
I'm trying not to run too long. I have a wonderful lab who feels that I need to be up at 4 o'clock every morning, and lately my 3-year-old has thought basically the same thing. So I normally would have been upstairs an hour ago to start winding down. So I don't want to run too long for myself either, but I'm definitely not going to cut off here to at least let you guys see some of live MDS switch here. This one is actually going to be, this is one of the Cisco PEC labs here, the Global Online Lab Delivery Labs, as I call it. So you get an idea of you're gonna have the worksheet I showed you before, which is, it tells you how to access things, walks you through. It actually will walk you through every single task, showing you exactly what to put in, what to do. Or you can just read the first description and, if do the initial setup. Well, the initial setup of an MDS is pretty basic. They've already given you the IPs, VSANs, everything you need. So you could do this task either following along, or you could just do it from scratch if you know what you're doing, you're just practicing. I know what I'm doing, but I don't necessarily remember all the ports I have configured on this topology, so I might cheat and look at this on the other screen. So the initial setup, this window I have open is this MDS 9148, 48 ports, 1 rack U, I believe 2 gig Ethernets for FCIP, just a nice little switch. I'm going to say it's 4 gig, but I won't swear to that until we get through it. If you've set up a Nexus device before, this is going to look very familiar for a lot of this. So yeah, this basic configuration dialog is going to look a lot like any other Nexus. We don't want another login account. We don't use SNMP. Obviously there's things you are going to do if you're doing this for real, but you're not going to do in a lab. Always want to configure your management interface, otherwise how are you going to use it? One thing you'll notice, while NXOS is based on ScreenOS, started on these devices, there's a lot of things that have been added on the Ethernet switches that still aren't in place on the Fibre Channel switches, and one of them is going to be that for Ethernet interfaces, you still have to configure your full net mask. You can't use just you can't just say 10.2.8.53/24. You're going to have to type it out. So, advanced IP options, you're rarely going to look in, and I couldn't even tell you what most of them are. No. Okay, so IP routing, static route. You're very likely never going to use the advanced IP switches or the advanced IP options on your switch, but then you get into the same stuff that you'd set up on a Nexus. You're going to set up SSH. Nobody should be using Telnet. The MDS does default to the HTTP server. I've never used it. It can be useful. Clock, time zone. So far, all of that's the same stuff you see in setup on a Nexus switch. Now you're going to get into some of the things that are just configured on the Fibre Channel switches. The default switch port, shut. A lot of configurations, especially with port channels on Fibre Channel, you want the port to start off shut down first. You want to configure both ends and then bring them up. Obviously, a lot of people will tell you to do the same thing in Ethernet, but most Ethernet switches, LACP, will still, detect the other ports. It'll bring the port channel up and do things cleanly. Fibre Channel has the port control protocol. It's, in theory, it's similar to LACP. It doesn't work as well. You definitely want your ports defaulted to shut down for things like port channels, or they're not going to come up to start. You're going to have to shut them down, redo it, bring it back up, make sure the config matches on both ends, and then bring it up. Default trunk port mode. This defaults to on. It has some relevance as to how you configure the switches. If you're running all Cisco switches, it should never be a problem. If you're interoperating with other vendors, you may want to set the default trunk mode to off and only turn it on for switches when ports that are connected to other Cisco Fibre Channel switches. Some vendors support it, at least in theory. Even switches that support it, I haven't always had it work. I tend not to trunk between vendors. If they do support VSANs and I have them configured on both sides, I will run a separate link for each VSAN. It's just, I've been doing this for years. I've never had good luck with it. If you're running all Cisco, don't worry about it. Leave it on. Be happy. Default switch port mode is F. If this is going to be connected primarily just all to end hosts, if this is your top of rack switch, go for it. You're going to configure 4748 as your uplink, have everything else set to switch port mode F to connect to end hosts. It saves you one step on every port config. It's not a huge concern because you're going to get in the habit of when you configure the ports and configure them for the VSANs, you're going to configure the switch port mode anyway, and probably the speed. So it can be useful. It's not a huge thing. The default zone policy, permit versus deny. This one's pretty important. Most any modern switch is going to default to a deny. This is just like your ACLs, your deny any as the last line, the implicit deny. That's what this is. If you change it to permit, even if you don't have devices zoned together, if you leave it on default permit, they're still going to be able to talk. Then you're just relying on LUN masking or the configuration on your storage arrays to make sure that only the storage that belongs to a host is presented to it. Not a concern if you have your array set, if your storage guy has the array set up correctly, but it can be bad if you have hosts trying to write to disks that they don't own. So leave it on deny. Enable full zone set distribution is set. It goes together with this, setting the default zoning mode, which I had meant to go over, but ran out of time. I might actually slip a bit about that into next week's. Basically, there is basic and enhanced zoning. They both work. They give you control of different alias types, which let you use more user-friendly names and shorter names when you're configuring your zoning. So you don't have to work with the longer, the more esoteric SCIDs or the longer miserable PWWNs. I don't think you'll need to know much about that on the test. You need to know that you'll probably need to know there's two different kinds. I don't think you're going to need to know anything deeper than that. Take a look at the book though. You might need just to know the difference between an FC alias and a device alias. And then that's it. It shows you your whole config here, what's being configured. We stuck mostly with defaults, so things are just going to be left alone. And you write the configuration and save it. The only thing else I was going to show is just a few of the verify commands. Obviously, anytime you're working with a Cisco device, there's certain things that you're going to have to get used to looking at to verify that things are configured correctly. Things like show conf, geez, it's been a while since I've been in show run. Look at your config. It's the same thing with a fiber channel switch as with an Ethernet switch. You're just looking to make sure you haven't made any mistakes. I believe you can use your regular show run, include, or begin with the fiber channel switches that you can with a Nexus. Let's see. Yeah, so those commands are all the same. What you're going to start to look for, though, are things that are more specific to fiber channel versus your Ethernet. So show int brief, your regular thing you're used to here. But here on the fiber channel switches, you have a few more columns that you may not be used to. So you have your VSAN. Just like every Ethernet port has a default VLAN or a native VLAN, every fiber channel port's going to have the native VSAN. Here, FX, we discussed before the E, F, NP, FL modes. FX is a mode that lets the port run as an F port or an FL port. It automatically detects if there's a loop device on there and will switch to run as FL. Trunk mode, as we discussed, is on. The status, this is going to look a lot like your Nexus. You have your up, admin down, not connected, SFP absent. These are different SFPs for fiber channel than for Ethernet. And it's not just the speed, it's because of that 8B, 10B encoding we discussed earlier. Here you see that the FX operates in F or FL. FL is generally going to be your storage arrays, or if you have some really old stuff around and hook a fiber channel hub up to one of your switches, your speed, your port channel. Most of this looks just like your Nexus. Every time a fiber channel device connects to a switch, it does a fabric login. This is where, if you're working on an Ethernet switch, you might do a show IPR, show MAC address table. For a fiber channel switch, you're going to look at show floggy database. This is showing you your worldwide port names that we discussed, worldwide node names, the fiber channel ID. So this is, so VSAN, okay. Give me a sec. So on port FC11, we see that it's in VSAN 57. We see the worldwide port name, worldwide no name. I can tell you right now, if it's 2000, that's probably going to be an end host, a server. C5 or 50 to the start is generally going to be disk. Nothing you need to know. It can just make life easier tracking things down. You may notice, if you remember, I said each switch has a domain ID, which is the first 8 bits of this FCID. You'll notice, though, that these are different. It's because of the VSAN. Each switch has a unique domain ID on each VSAN. Oh. So VSAN 57, the current domain ID for this switch is 37. VSAN 58, the current ID is 16. That's why there's different FCIDs, the different first 8 bits on the show floggy database, despite it being from the same switch. There's also a show FCNS database. So floggy is just the fabric login to devices that logged into this particular switch. FCNS is a Fibre Channel name server database, and that will give you the login of the fabric login of every device on that VSAN. But I did not finish the configuration on our other switch, so FCNS is still the same 5 devices as here. I think that's about it. There's other verification, but you start to get into things we didn't set up. So we can do, here, this is going to be pretty similar to your show int on an Ethernet switch. You do have a few other things though. So your FCID, we still see the same FCID we saw up there. We get to see the port mode again, the port speed. Here are the B2B credits I talked about. So in general, you're going to have, for an F port, you're going to have more receive credits than transmit B2B credits, because generally you're receiving frames in from the host versus sending them out. You see your MTU, which is important if you're running FCIP. You're generally going to run your FCIP Ethernet ports at 2300 to have enough room for this MTU plus overhead. And I think that's about it. I feel like I'm just kind of rambling here. And so let's see if there's anything left in the slideshow. The MDS family, which I didn't populate, and it's probably good because we don't have time. That's about it. I hope you guys learned something. Feel free, email me, catch me on Twitter, which was @JWSConsult. It's been a couple years since I've been through this, but I use all this equipment every day. I'm happy to answer any questions. Obviously, all the vBrownbag guys are great, so if you forget my name, email address, Twitter, anything about me, reach out to Anthony or Cody or Jonathan, and they all know how to track me down. I'll be happy to answer any questions.
Awesome, we appreciate it. We're getting some good feedback in the questions section, thanking you, and great info. So I think it was well appreciated here with the people live, and I'm sure people will appreciate it when this gets recorded. I don't know if I mentioned it at the beginning. Of course, all of our stuff is recorded on YouTube. We throw it up on our YouTube channel. We have it on our iTunes, so you can subscribe that way if you want to. Yeah, great info. If you have any questions or comments, toss them to me, toss them to Joel on Twitter. Hit up the vBrownbag hashtag. Somebody will see it and should get back to you. I don't have anything else on my end, so I can probably stop the recording. So anybody that's watching, thanks for listening, and have a good evening. Where's that button?